Hello students, today we will discuss some more partial differentiation problems. Here u is given as e power xyz, then show that this is what dou square u by dou x dou y dou z. So we need to take here 3 times partial differentiation. First of all starts from right to left. So first of all partial differentiation of u with respect to z after y after x. So that's why we are writing this as what? Dou by dou x of dou by dou y of dou u by dou z. So this we need to find first. For that partial differentiation of u with respect to z. So here dou by dou z of e power xyz. So it is in the form e power z form. E power z derivative is e power z. But instead of z, xyz is given. That's why dou by dou z of again this function xyz. Now here this is as it is, and with respect to z we are doing in the sense xy are constant. So xy constant, take it as it is, and z derivative with respect to z is 1. So xy into 1 is xy. This is what dou u by dou z. Again partially differentiate equation this with respect to y, then we are getting what? Dou square u by dou y dou z we get. So dou by dou y of this total function. Again this is what with respect to y we are doing means this is one function in y, that is u into v. So derivative of u dash v plus uv dash, in the sense derivative of this with respect to y means x is constant here. X into y derivative is 1, that is x into v as it is plus u as it is here, and derivative of e power x is e power x, but instead of x, so with respect to y we are doing means instead of y here we have xyz. So dou by dou y of xyz. See, then take this as it is up to here, and with respect to y we are doing means xz is constant. So xz into y derivative is 1, that is xz. So from these two we can take x into e power xyz as common. Then this is 1 here. Here we are taking only e power xyz as common, because when you are taking x is also common, then in the next part we have 3 functions. So it is lengthy to calculate. That's why we are taking only e power xyz common, then x plus x into x square yz here. Again we want dou cube u by dou x dou y dou z for this function. So we need to take the partial differentiation with respect to x on both sides. So dou by dou x of this function. Now here it contain x, and here also it contain x. That's why it is in the form of like u into v. That means u dash v plus uv dash. So u dash derivative of e power xyz is e power xyz, and also with respect to x again we need to take the differentiation of xyz. So with respect to x we are doing means yz is constant into x derivative 1. So yz here, and this is u dash into v, take it as it is, plus u into u is this one, and v dash derivative of this with respect to x here. So x derivative is 1 and x square derivative is 2x, and this is constant. So constant into function is constant into this function derivative, that is 2x into yz. Now from these two e power xyz common, then what will happen? Here x into yz, xyz, here x square, y square, z square, and here 1, here 2xyz. Now here 1 here, and xyz plus 2xyz is 3xyz, x square, y square, z square. So hence prove. Another one, u equal to log of tan x plus tan y plus tan z, then prove this condition. So take u in the answer. We need to prove this one. For that here partial differentiation of u with respect to x one time is there, with respect to y, with respect to z. So we are finding these values by taking partially differentiate equation 1 with respect to x first of all, then dou u by dou x of this one. Now it is in the form like log x form. Log x derivative is 1 by x. So 1 by, instead of x here this function, so take it as it is, and again dou by dou x of here, dou by dou x of this total tan x plus tan y plus tan z. Now see here, tan x with respect to x, tan x derivative is secant square x. Here I am taking directly, and dou by dou x of tan y, so which contains what? No x term, so it is obviously a constant. So dou by dou x of tan y is 0, dou by dou z of tan z is also 0. That's why we are taking only secant square x here by denominator as it is. Similarly, partially differentiate equation 1 with respect to y we want. So dou by dou y of this same as previous, log x derivative is 1 by x. Again differentiate this function in the sense with respect to y we are doing means x and z are constants. Only tan y derivative is secant square y. Similarly, with respect to z means dou by dou z of this. So log x derivative is 1 by x, but instead of z here this total function with respect to z we are doing in the sense x and y are constant. So tan z derivative is secant square z. Now take LHS. What is LHS? Sin x into this one plus sin 2y into dou u by dou y plus sin 2z into dou u by dou x. Substitute all those values dou u by dou x, this and this in LHS. See here tan 2x into dou u by dou x. Similarly, substitute all those values. Sin 2x is nothing but, simplify this. Sin 2x is nothing but 2 sin x cos x. We have the formula. And secant square reciprocal is 1 by cos. That's why 1 by cos square x, because here in terms of sin and cos is there. That's why we can convert this secant in terms of cos. So 1 by cos square by denominator. And similarly sin 2y, 2 sin y cos y, 1 by cos square. Similarly for z. Now cos gets cancelled for every term and remaining terms are 2 sin by cos is 2 tan x, 2 sin y by cos y, tan y. Again 2 sin z by cos z is tan z, by denominator is same. Here we are taking LCM, that's why we are taking the common denominator. Now 2 taken as common, then these values gets cancelled, then the answer will be 2, which is nothing but RHS. Now find the first order partial derivatives of tan inverse x and y. So consider as some function either z or u. Suppose I am taking here u equal to tan inverse of x plus y. Here it is asking for first order partial derivatives, means how many independent variables we have? 2. That's why we have 2 first order partial derivatives, that is dou u by dou x and dou u by dou y. So we can take dou u with respect to x partially, then dou by dou x of tan inverse x. So instead of x, x plus y is there of course, and tan inverse x derivative is 1 by 1 plus x square, and instead of x, x plus y is given, so dou by dou x of that x plus y. Now take this as it is, and derivative of x with respect to x is 1 plus with respect to x, y value is 0, because with respect to x we are doing means y is constant. So here 1 by 1 plus x plus y whole square. Similarly, partially differentiate equation 1 with respect to what? Y. Dou by dou y of, again it is having y term, that's why it is a function, that's why tan inverse of y in the sense 1 by 1 plus y square. But instead of y, x plus y is there, so x plus y whole square. Again differentiate dou with respect to y, dou by dou y of this one. So similarly with respect to y we are doing means x is constant, so 0, 0 plus 1 here, so 1 by denominator. Similarly we can see another problem. U is given as e power ax sin by. First of all, first order means with respect to x we are doing first, then here this is function and it contains only y, not x, that's why it is a constant. So constant into function means take the constant as it is, and function derivative is e power ax derivative is e power ax into a. See, constant take it outside, and e power ax derivative is e power ax into dou by dou x of again ax. Ax derivative is a. So a into e power ax into sin by. Similarly, partially differentiate equation 1 with respect to y in the sense with respect to y we are doing means x is constant. So e power ax constant into this function derivative. Sin by derivative is cos by. Again instead of y, by is given. That's why derivative of by is b. So see another one, log of x square plus y square. It is also the combination of x and y. First of all, partially differentiate equation 1 with respect to x. Then it is like a log x form. Log x derivative 1 by x. Again d by dx of dou by dou x of this term means x square derivative 2x. So 2x by. See, partially differentiate equation 1 with respect to y means dou by dou y of this one. So log y derivative is 1 by y. Again differentiate with respect to y means this is constant 0 and y square derivative is 2y. See this, u is given tan inverse of x by y plus sin inverse of x by y plus tan inverse of y by x. Then show that this condition. For this only first order partial derivatives we need to find. So partially differentiate equation 1 with respect to x means dou by dou x of this one, right? Now x, it contains x, so it is a function obviously. And sine inverse x derivative is what? 1 by root of 1 minus x square. D by dx of sine inverse x is 1 by root of 1 minus x square, right? So 1 by root of 1 minus, instead of x, x by y is given, so x by y whole square, again dou by dou x of that term, that is x by y, plus similarly it also contains x, means it is a function, so tan inverse x derivative is 1 by 1 plus x square. X square means y by x whole square, again dou by dou x of that x term. Now take this as it is, take LCM y square here, then y square minus x square by y square here, and with respect to x we are doing means constant is 1 by y, so 1 by y into x derivative is 1, so 1 by y. Here take LCM x square, then x square plus y square by x square, and with respect to x we are doing means y is constant, take it as it is, and 1 by x derivative is what? Minus 1 by x square. That's why with respect to x we are doing means take y as constant here. Now take it into numerator, root of y square is nothing but y, take this y into numerator, so y by root of y square minus x square into 1 by y here, and similarly take this by y x square into numerator, x square by x square plus y square, plus into minus here y by x square gets cancelled, y gets cancelled, then 1 by root of y square minus x square minus y by root of x square plus y square. Similarly in the question dou u by dou y is also asking, so we need to take partial differentiation with respect to y, so dou by dou y of this total term. Now see here, dou by dou y of this means it is also contains what? Y. That's why it is a function. So sine inverse y derivative is 1 by root of 1 minus y square. So instead of y, x by y is given. Again dou by dou y of x by y, right? Dou by dou y of x by y, in the sense with respect to y we are doing means x is constant, x into 1 by y derivative is minus 1 by y square. So minus 1 by y square into x here. Similarly tan inverse y form it is. Tan inverse y means 1 by 1 plus y square, but instead of y, y by x is there. Again differentiate with respect to y, in the sense x is constant, so 1 by x constant as it is here, and y derivative is 1. Okay, understood? Now see, take this as LCM. I have taken here directly by y square LCM here. So by y square root, take it into numerator, then it will be y square LCM, in the sense y square minus x square here. Here by y square, in the sense take it into numerator, root of y square means y here, and minus of x by y square. Here also by x square LCM, take it into numerator, and x square plus y square here. X gets cancelled. This is minus x by y into this, plus x by x square plus y square. Now in the question it is given as prove that this equal to 0. For that consider LHS value, x into dou u by dou x, substitute that value, plus y into dou u by dou y is this one. Now multiply x by root of minus x into y by x square plus y square. Here plus into minus xy by y into plus x into y, xy by. So here y gets cancelled. Now see here, this taken as it is, and x divided by root of plus xy by this. So here same with opposite sign, so 0. So this value is 0. Z is given as here f of x plus ay plus pi of, it is another function, x minus ay, then show that dou square z by dou y square equal to dou square z by dou x square in a square into, right? Here in the question it is asking dou square z by dou y square, means we need to take, here we have to take differentiation of z with respect to y 2 times, here x 2 times. So for that partially differentiate equation 1 with respect to x first of all. So dou u by dou z by dou x, in the sense dou by dou x of the same function. So here with respect to x means it is a function, so f derivative is f dash of x plus ay. Again instead of x, here x plus ay is there, again differentiate with respect to x this function. Similarly here it is pi derivative is pi dash of x minus ay, again dou by dou x of this function. See, take it as it is. With respect to x means it is 1 plus this is constant 0, right? It is 1 into 1 is this one, and pi dash x minus ay with respect to x means this is 1 minus 0. So take it as it is. Again partially differentiate equation 2 with respect to x means again differentiate. Then it will be f double dash of this, again differentiation means into 1. Here also double derivative into 1. Similarly partially differentiate equation 1 with respect to y here. So f derivative is f dash, again differentiate this with respect to y means x is constant 0 plus ay derivative is a. Similarly here pi dash of this, again this derivative is here coefficient minus a. Now here take a as common, or you can take as it is a into this minus a into this function. Again differentiate with respect to y because here we have 2 times differentiation. So again a take it as it is, f dash derivative is f double dash, again differentiate with respect to y in the sense here a. Similarly for this minus a take it as it is, f double dash of x minus ay. Then with respect to y means x is constant, here minus a. Ay derivative is minus a. From these two, a square taken as common, f double dash of this minus into minus plus pi double dash of x minus ay. Now dou square z by dou y square, dou square z by dou y square equal to a square into this value is nothing but dou square z by dou x square. So substitute instead of this value. So here we prove dou square z by dou y square equal to a square into dou square z by dou x square. Tomorrow in the next video we will discuss some more problems. Thanks for watching.